Hi everyone, this is chapter 22, Vasculature, which is your vessels, your blood vessels in your circulation. Um, it's a long chapter, so make sure you are caffeinated or whatever to follow along. Okay, so chapter 22's outlines in front of you. Let's get started. What you're looking at, this is a really cool picture of a body that has been it just shows you the blood vessel network, right? So the images from Body Worlds. Body Worlds will take human bodies and then put plastic into the parts of the body that they want to keep and they want to display, and then they'll sort of melt away chemically the rest of the body. So kind of like Breaking Bad, if you saw Breaking Bad, they really just dissolve the body. So this is a really cool image of the just the mind-boggling amount of blood vessels we have in the body. But also keep in mind that these are the visible blood vessels that we can see with the eye, so they're big enough that we can see. There's even more blood vessels that are microscopic, right? The capillary system is extensive. So this is an estimated 50,000 to 100,000 miles of blood vessels in your body. This is the vasculature network of your brain. So we'll be looking at the major blood vessels in here. So you can see that we have larger ones and we have smaller ones, right? The larger ones will be named. The smaller ones are too numerous to be named, and they're going to be a little different for everybody as well. So everybody's going to have the same basic large and medium-sized blood vessels, but when they get to the smaller blood vessels, that's where you have variation between people, and there's so many of them that we don't name them, okay? This is a nice SEM of an artery. And what I want you to appreciate here is that there are three layers, and we'll talk about these three layers. So we have the lumen, where we see our erythrocytes or red blood cells. We have this purplish layer that's tinged pink on the end. That's going to be the endothelium, or otherwise known as tunica interna. So it's the lining of your blood vessels. We talked about this with the heart, right? We talked about how in atherosclerosis, there's fat and lipids deposited underneath this endothelium. So this actually stays intact as your plaque builds up underneath it. The second layer of your blood vessels is this green layer, and that's called the tunica media for the middle. And then we have the externa in yellow, okay? Tunica externa. So let's go ahead and look at the layers and look at letter A in your outline. So we have the three layers of blood vessels listed. The tunica interna is also called tunica intima. It's also called the endothelium, letter A. So endothelium just means it's an inner lining, and it's going to be simple squamous simple squamous epithelial cells. And in the larger blood vessels, it might also contain some elastic tissues because the larger blood vessels will have to expand to accommodate blood flow. Tunica media is going to be your muscly layer. So if you take a look at your images here and just take a look at our large artery, the tunica media is relatively thick, right, compared to the other layers, the tunica media on a muscular artery. And it's this color because that's what the textbook uses to depict muscle, right? So smooth muscle is in the wall of your arteries and also your veins. You see here in this venule, there is no smooth muscle layer, right? So that's accurate. And then your small, tiny capillaries, there's no smooth muscle as well. So we'll talk about that. So in this layer, why do you need muscle in the blood vessel walls? If you remember back to the blood or the skin lecture, you know that the blood vessels can contract or dilate, right? They can vasoconstrict or vasodilate, and that is the smooth muscle at work. So it is to regulate the amount of blood flowing to a part of your body. If it's in your skin, the function really is to either dissipate heat or not. But if it's to your organs, right, your body can actually control which organs are going to get blood flow. So if you just ate a meal, then your digestive organs are going to have to get more blood because they're working, they're digesting, they're absorbing nutrients. And so the digestive organs will have the blood vessels leading to them will dilate, and so more blood can rush to those organs, whereas it might constrict a little bit to maybe deviate away from your skeletal muscles if you're not using your skeletal muscles, you're sitting and you're eating. or, you know, after you eat, you're watching Netflix. Okay, so your body can really fine tune where the blood goes, and where it's needed, the blood vessels will dilate. All right, so in Tunica Media, we have smooth muscle predominantly, letter A. We also have elastic and collagen fibers. So again, your blood vessels have to be elastic. They're not rigid structures. So when the blood is coursing through them, there's a give, right? So you can imagine that this is a good thing, because if your walls were rigid, they would tear. If you had maybe a surge of blood pressure, like you're under a lot of stress and your blood pressure goes up, your heart's racing because something exciting's happening. And so that elasticity really accommodates a rise in blood pressure. All right, so let's look at the tunica externa. This is also called the adventitia. So we can see the word here in this elastic artery. So there's our adventitia. Tunica externa is perfectly welcome to, you can use that. So this is going to be the hard, rigid casing of your blood vessels. So the inner lining and the middle is kind of soft and elastic. And then your outer lining is going to be the tough protective layer on your blood vessels. So it can be a little bit, you know, it's the protecting the wear and tear on the external surfaces. So it's going to stabilize the blood vessel. It also can help anchor the blood vessel to other structures around it. Okay, so what it's made of is dense connective tissue. So back to unit 1, dense regular or dense irregular connective tissue, but this is probably dense irregular. All right, let's look at the arteries, the capillaries and veins, so B, C, and D in the outline. All right, so let's just start with the blood leaving the heart. And the biggest arteries of your body, I'll just say, actually say singular, the biggest artery of your body is the aorta. Okay, so there's your aorta. This is going to be called an elastic artery. You only have one. Okay, so it's the aorta. As it goes behind the back of the heart and in your thoracic cavity, it's called the descending aorta. It's also called thoracic aorta. When it goes into your abdominal cavity, it's called the abdominal aorta. Okay, but that is classified as an elastic artery. It is getting the blood pressure. It is the highest blood pressure, because as the left ventricle contracts, the surge of blood in that left ventricle pushes on the wall of the aorta most forcefully, right? So this is going to have to be the most elastic because it has to expand the most. And as an added bonus, when it recoils, when your blood vessels go back to its sort of normal shape, it helps to push the blood down, you know, to your body. So that recoiling action is really important for helping your circulation as well. Okay, so number 1, elastic arteries. They're named for their diameter. So I have the aorta and major branches off the aorta, but for your purposes, the aorta is fine for elastic artery. And we talked about number 1. It also helps to dampen the blood pressure slightly because it is coming into a narrow organ, right? So it's going to dampen a little bit. So just like the arteries down the road are not going to get so much force. They're not going to be as thick. They can't accommodate that massive force like the aorta can. All right, so the elastic artery is number 1. The next size artery is going to be your muscular artery. And this is also called a distribution artery because these are the arteries that distribute the blood to the organs. And they're oftentimes named after their organ. So if it's going to the kidneys, it'll be a renal artery. If it's going to your stomach, it's called a gastric artery. Okay, so we will learn the names of muscular arteries in this lecture. All right, in the muscular arteries, the muscle layer, that tunica media, is the thickest. All right, so out of all of your arteries, the tunica media is thickest in your muscular arteries. And again, I have vasodilation, vasoconstriction. So these are the arteries that really control, because they do lead to organs. These are the ones that can really control the blood flow to an organ. All right. Then when muscular arteries get smaller, so every time these blood vessels branch, they get smaller. And so the next level down, we're going to have arterioles. So arterioles are going to lose a layer. You can see that they lost the adventitia. So they're going to be pretty delicate. They do still have their smooth muscle. They still have their endothelium, okay? And arterioles are still considered arteries because they're still carrying blood towards, away from the heart, or towards an organ or away from the heart. Okay, now let's look at capillaries. So by the time your blood has come into a tissue, an organ, right? So let's say we're talking about your kidney. The muscular artery is going to just be called the renal artery. It goes into the kidney. But once it enters the kidney, then it's going to start to branch and it's going to start to change names. And then the smallest ones will be arterioles. And then you have to start to diffuse your nutrients, right? So the blood is going to your organs. And at some point, the whole purpose of this is to diffuse your oxygen into your tissues and receive the carbon dioxide away from your tissues, and also deal with your nutrients and waste products, right? So we need some kind of exchange of materials with your organ. And that's what the capillaries do. So the capillaries are going to be the smallest, they're microscopic blood vessels, and they are only going to have one layer. They only consist of the endothelium, okay? So again, the endothelium is a simple squamous layer of those endothelial cells, okay, or epithelial cells. I'm going to flip to another picture of this. All right, so here's your capillaries. So the capillary walls are so again, I want to stress this. Capillaries are the only blood vessels that allow diffusion to take place across their walls because their walls are so thin. There's only that one layer of endothelium, and it's diffusible. So there are two kinds of capillaries in your body. This one here, called a continuous capillary, is the most prevalent one in your body. It's pretty much like the picture sort of illustrates. The cells, these squamous cells, are tied together, right? There's no gaps between them. But however, right, the wall is thin enough that you can get passage of materials. The second kind of capillary we have in our body is called a fenestrated capillary. So the word fenestrated means porous. So you can see from the picture here how there are regular pores all throughout the capillary. These capillaries are going to allow, as you may intuit, they're going to allow more materials to flow through their walls. So the fenestrated capillaries will be in areas of your body that really want to have a high amount of larger molecules go through them, or they are basically a filtering kind of organ. So let me give you two examples. I think they're in your notes. One is going to be the kidney. Let me just find this under capillaries. Oh no, I don't have examples, but I'll give you some. So in your kidneys are responsible for taking all the waste products that are in your blood, right? You got to filter all that waste into your kidney so that it can eventually create urine, and all the waste products leave your body in urine. So we're going to have a lot of fenestrated capillaries there. And we'll learn them when we do the urinary system. And then there's another set in your pituitary gland. So remember, we talked about how the pituitary gland makes hormones. Those hormones are larger molecules and they need to enter the bloodstream immediately. So there's fenestrated capillaries there, okay? So they're both diffusible blood vessels, except the fenestrated one is just slightly more leaky, right? It's diffusible for larger and more and larger molecules. Okay. So let's look at our veins. So actually, let's stay on here. Number 2, capillary beds. Yeah. So this is what happens when you form a capillary. It's not just one single capillary, it's an interconnected network of capillaries called a capillary bed. And the capillary beds are controlled. So you have tiny little muscles, these smooth muscle sphincters called capillary sphincters, or you can say precapillary sphincters. And they can actually just like micromanage the blood flow to very small areas of your body. So you can completely, if these sphincters were to contract, right, it cuts off the capillary bed, and it can divert blood away from that area of your body. When you have, if you're really cold and just the tips of your fingers, that skin turns white, it's really the capillary network that's going to get squeezed off, right? So your body is really controlling you know, I guess your body thinks that you don't need the tips of your fingers, right? So that can go if you're really, really cold. So I wanted to show you that, right? So it's a capillary bed. And when blood is flowing down into your capillaries, right? Here, again, remember we talked about this in the red blood cell. These are so small that only one red blood cell can fit through at a time. And so they end up stacking on top of one another and they form a rouleau. This is where the blood really slows down and you have diffusion occurring across the blood vessel walls. When you see the color change, right, you're seeing the red blood, which is the color they use for oxygenated blood, turn to blue, right? There's a purple area in the intermediate and then it turns blue. Blue tells you it's oxygen poor blood. There's going to be a pressure switch. Here, there's nothing driving the blood flow other than a pressure system. So the blood is really being pushed by your heart into your capillaries. It slows down. The exchange happens across the walls. And then there's a pressure change where the fluid actually starts to go into your veins. And then the veins will take that blood and route it back to your heart. All right, so the capillaries on the venous end will then connect to your smallest veins, which are called venules. All right. So now let's talk about veins. All right, so let's look at that picture in a second. Let's go back up to all right, so here we are. The smallest of our veins are called venules, right? So they're gathering the blood from our capillary beds. The blood is going to pool into our venules, and then those will eventually lead into medium-sized veins. The medium-sized veins will take the blood and eventually coalesce into your large veins, and of course, ultimately into your heart, the right atrium, so that it can complete the pulmonary circuit and repeat everything over again. So we can see that the veins here, or I'm sorry, the venule does not have smooth muscle. If you think about this, because the smooth muscle is for really, controlling the blood flow, if you look at the comparison between the two, it's the arteries that really are the deciders, right? The arteries are going to really make an impact on whether the blood's going somewhere or not. The veins, their job predominantly is just to route all your blood back to the heart. So the muscle wall of the veins don't have to be very thick. In venules, don't even have them. Okay, so the venules don't have a muscle wall. They don't have the tunica media. They're going to gather the blood and they're going to move it towards a medium-sized vein. The medium-sized veins, you're going to learn the names of some of these, right? And they have all the layers, and then we're going to move on to large veins. What are our large veins? Our large veins, also called great veins, are the inferior vena cava and the superior vena cava. So this is written under letter D, veins. Okay. Number 2, we have medium veins and we have large veins. So if you're looking at your outline, you already see how blood moves inside of your veins. And this is a question that I kind of have fun with, because no one ever thinks about how does blood get back to your heart, because we all know that our heart pumps blood to our body, but how does blood get from your big toe back up to your heart without another pumping system, right? So veins have a mechanism inside. They have valves. Let me show you the valves. Here they are. So veins will have, regularly spaced valves within their lumen, and they move the blood inside of your veins by the movement of your body. So every time you move your body, you contract a skeletal muscle, the skeletal muscle will push on that vein. And the walls of veins, you guys, are thinner than the walls of arteries. Okay, so they're susceptible to being smushed more than the walls of arteries. So every time you move and contract a muscle, you're going to push on those veins, and the veins, the blood will go up and the blood will get pushed down, right? But what happens is the blood that's moving down stops at a valve because the valve will close. And so the blood it cannot go any further than that valve. However, when blood goes up, the valve naturally opens and allows the blood to go up, and then the valve closes, so the blood stays in that segment. So throughout the day, every time you move, you're basically moving the blood in your veins back up to your heart. via the skeletal muscle contraction and the function of the valves. Let me show you faulty valves. So number 3, varicose veins. This is very, very common, right? I think everybody might have some varicose veins. Varicose veins are where the valves are not working efficiently in your veins and allows blood to go back down to the previous segment. And if imagine that the previous segment might have more blood in it than it should, and the walls of that vein will stretch and it will bulge over time, and it might show up as bulging vessels underneath the skin. Sometimes they show up as these red lines underneath the skin. But either way, it's the excess amount of fluid within the veins that causes that bulging to happen. Varicose veins, in terms of what causes them, there's a lot of reasons. Sometimes people are born with just faulty valves. The valves don't close that well. And I have a friend who, very young in college, so he was in his 20s, and he had varicose veins that looked just like this picture. So he was basically born with valves that were a little inefficient, right? Sometimes and then other times they form when a woman gets pregnant. It's very common that she'll develop varicose veins because, and I can't remember if it's double or triple, but the blood volume and the fluid volume of her body really triples or doubles, like I said. And so there's just a lot more fluid in a pregnant woman's body that will then stress the veins and cause varicose veins. Another cause of varicose veins can be people who just stand for a very long time. So if your job is as a security guard, or if it's someone who is checking people out at the grocery store, you're basically standing in one position for hours and hours. And so you're not moving your body the way it should be moved. And so because of gravity, right, the blood will pool in these segments of the veins and cause pressure on the wall again. So that's varicose veins. So you should know about that. Okay, so in number 4, I just mentioned that the blood moves through via skeletal muscle contraction. All right, so let's go back up to our comparison between arteries and veins. All right, so this is usually what I do through class, but let's just do it. For me, I'm going to do it alone. Which one, and this is just looking at veins or arteries, which one has a thicker overall wall? So all 3 layers together, which one looks thicker? Okay, so I want to just look at these 4, compare the large and medium veins with the large and medium arteries. You should come up with arteries. Arteries, overall, their walls are much thicker. And in gross anatomy, if you had a cadaver, that's the way you can tell the difference between an artery and a vein. Is an artery will be round and kind of plump, and then a vein will be collapsed and kind of flimsy, because the wall is just a thicker, more robust wall on arteries. And this is because arteries, remember, they carry blood away from the heart. They're under greater blood pressure. The blood is being pumped through them. So their walls have to be thicker and more protective to accommodate that blood pressure, right? Veins are low pressure systems. The blood running through them is not under any force, right? It's just kind of the skeletal muscle moving. So there's no need for a very thick wall. So overall wall, thicker artery. Larger lumen. If you look at the lumen, it's going to be veins. So veins, most of the blood in your body at this moment is in a vein. So the lumens are larger to accommodate that. Let's see, tunica media thicker. So hopefully this is pretty obvious. Arteries, both the elastic and the muscular, they have a thicker media. Which one has a thicker adventitia? And that will be your veins. So because they don't have that thick media, they're going to have a thicker adventitia to protect their structural integrity. Which one's going to be more elastic? Hopefully this one is a little easy and intuitive. It has to be your arteries, again, because they're under blood pressure. They have to expand and recoil. They're going to have to be more elastic than your veins, which are not under blood pressure. And then which one has valves? And these are only veins. Okay, it's just your veins. Venules and veins have valves. All right, let's look at the histology slide. So part of this exam on chapter 22 will be identifying the difference between arteries and veins in a histology slide and identifying the 3 layers. And this is pretty simple. You just have to look at a few key characteristic differences. So let's look at this middle picture. The first is that the lumen of arteries and the lumen of veins will be different. The lumen for arteries will be smaller, the lumen of veins will be bigger, and also the lumen of arteries tend to be circular because the structure itself is thicker, and so when you slice through it, the structure itself remains circular. But for a vein, an empty vein that has been cut through will collapse because the walls are thinner, okay? So the lumen of veins are usually collapsed or not perfectly circular, whereas the arteries are a little bit more circular. The second thing that you want to look at is the tunica intima, all right, or the endothelium here. Notice in this cartoon, they have a sort of wavy or scalloped edge of your tunica intima. And then here they have a smooth endothelium or tunica intima. So the reason why this is scalloped is because arteries are made to expand under blood pressure, so that this is extra tissue so that when it does expand, it can stretch. Okay, so it stretches and has that extra tissue in the inside. Veins don't need to stretch, right? They're not under blood pressure, so they don't have that extra tissue in their tunica intima. All right. The other feature that is probably pretty obvious here is just the overall thickness of the wall. So the artery walls are very, very thick. Tunica media is the thickest here, and then you can see the overall wall of the vein is pretty thin compared to the artery. Okay, so let's take a look at our practice histology slide. Letter A is in the lumen of, you should say artery, right? This is the artery. Letter B is in the lumen of the vein. And what is C? What is C doing over there? So C is neither an artery nor a vein, because C is completely filled, right? It's not hollow, it is a solid structure. So I'll tell you, the answer is a nerve. And so I make the analogy of if you have a television, right, or some electronic equipment, and you want in your outlet is 5 feet away, you usually will bundle all the wires that you need to go to your electrical equipment together and then run them to from the outlet to your TV or whatever together, right? So they're packaged together and they run together. So it's kind of a neat pathway to a destination. Your body does the same thing. So your arteries, veins, and nerves that supply a certain area of your body will always run together. So when you see a histology slide of an artery, I mean, it's going to also have a vein. It's also going to have a nerve next to it. So I want you guys to recognize the nerve. All right, and then hopefully you can see the 3 tunics too. So this golden color that looks a little bumpy right here, that's going to be your tunica intima. The pink is your tunica media, and this dark black purple is your tunica externa. Okay. On your vein, the tunica intima is very difficult to see, but it's the darker staining cells here. Remember, epithelial cells have dark staining nuclei close together. Where it becomes a little bit more pale, that's your smooth muscle. And then where it's dark is your tunica externa. And then we have a lot of adipose in the background, so hopefully you guys recognize that that's adipose. All right, I think we are done with this unit. I think I have a question for you. This is just an appreciation of your blood vessel network. The larger guys here, these are arterioles. And then you have another classification called meta-arterioles, which I didn't even mention. And then we have capillary beds. So the really tiny structures in between, right, those are capillary beds. So you can imagine how many billions of capillary beds we must have in our body. All right, so the transfer of oxygen to the body's cells takes place where? So you can pause it, think about it, but the answer is only letter C, capillaries. Arteries, arterioles, and venules are too thick, their walls are too thick to have anything diffuse across into the tissues or away from the tissues. So the only transfer, the only diffusion of anything takes place only at capillaries, okay? I think that's it. Oh, okay, find your valves.
Once it's occluded, take your other finger and just push that blood out of the vein. Where the blood backflows to, that's where the valve is. Gravity's pushing the blood back down the vein, but the valve, which is a one-way valve, prevents it from filling the rest of the way. And since I'm not allowing any blood flow to return to the heart, you can clearly see this area of the vein, no valves, that's where the valve is. This is where you want to put your catheter. So I'll show you that again. Occlude the vein, push the blood out of it, and wherever gravity lets it backflow to, that's the valve. It can't go any further. So you're going to avoid the tip, this area with the tip of your catheter. Give it approximately, if the valve's right here, don't get your catheter any closer than that. That way the fluid will fill it, the valve won't shut, and it'll actually allow it up the rest of the vein. And there it refills. Is that not cool? And very quick, very quick.